Hello. So welcome back, students. So now this is the lecture where I will discuss the different properties of any material, and this is very basic, and understanding of these properties um, is very much useful for any competitive exam or for any job interview which is related to mechanical engineering. Okay, so let us start. Properties of material. Okay, so first property, that is ductility. And second is malleability. Okay, these two properties are confused, very much mixed by the students appearing for the competitive exam or appearing for the interview. So let me give you a very crisp idea about that what is the basic difference between these two properties. Okay, so ductility is the property by which the material, it is the plastic response of material. It is the plastic response of material to the tensile load. This is the important thing, tensile load. This is plastic response to the compressive load. So here is the main and basic difference. Tensile load means if there is material and you apply tensile load and you convert this block into thin wire. Generally this kind of definition is given. If we convert any if we can convert the material into thin wire, it possesses ductility. But that is okay. But if we want to give a more, what we can say, more meaning to the definition, that it is the plastic response of the material. Why plastic? Because it is the permanent deformation. Okay, so plastic response of the material to the tensile load. Okay, and what the malleability is associated to? Suppose this is the block, and with the help of hammer I am applying blows, mechanical blows. Okay, I am hammering into onto this particular block, and I am converting into like this big sheet. Okay, so that is what is all about compressive load, which defines the property malleability. Okay, so there is the difference in load. This is related to the tensile load, and this is related to the compressive load. Both are the plastic responses of a material, but one is related to the tensile, which is known as ductility. One is related to the compressive, which is malleability. Okay, clear? Next is hardness. Okay, so what do you mean by if a material is hard? So if a material is hard, it is having scratch and wear resistance, means good resistance. Wear means you can say scratches, any kind of wear we can consider. So Hardness, if a material is hard, it indicates that it is having good resistance against scratch, wear. Wear can be any kind of uh, wear. Okay, indentation, you can say indentation. Okay, so that is the hardness. Okay, and the second is fourth is what you can say. Next is toughness. So toughness property is related to the impact load. Okay, so it is the ability of material to sustain the impact load. Okay, so if a material is tough, that means its toughness is very good. It can, if it can resist the, what we can say, the impact load, that material is particularly tough material. Or we know this graph, the entire area under this engineering stress strain curve, that is known as, that also indicates toughness, but it is known as modulus of toughness. Okay, that is related to impact strength. This indicates impact strength. Similar to this toughness, we have one more property, resilience. So what is resilience? That is related to absorption, or we can say storage of energy. Okay, if I have to explain it with the help of a graph, then again consider this kind of graph. Okay, and we know that there is a point, elastic point. So the area till the elastic point, this area is called or known as modulus of resilience. Let me write here, modulus of resilience. Okay, so resilience is the property or the ability of material to absorb strain energy when deformed elastically. Here main point is that elastically. Okay, so if we have to go through the points, okay, so toughness and resilience are very much same, but this is related to the impact strength and this is related to the energy till elastic point. Okay, this is related to the wear resistance or indentation resistance. Okay, then next is fatigue strength, or let us understand endurance limit. So endurance limit, that is the value of stress below which the specimen can withstand n number of cycles, fatigue cycles. Okay, below which the value of stress below which the specimen can withstand n number of fatigue cycle. Now here, what is fatigue? Fatigue means, let us understand with a simple example. Suppose this is the road that we have. Now we are bending it. So when we bend, suppose this is point A, this is point B. When we bend it like this, there will be positive stress over here and there will be negative stress. Positive means tensile, negative means compressive. When I reverse this thing, unbend it and bend it upward, so here there will be negative stress and there will be positive stress. So when we apply load with different nature means tensile plus compressive load. This kind of loading is known as fatigue loading. This kind of loading is known as fatigue loading. Okay, and in fatigue loading, the material fails below its what you can say UTS. Okay, that is a altogether separate discussion, but this is the important point to remember, that fatigue loading is very dangerous because the material can fail below its ultimate capacity. So that is a very dangerous thing. That is only possible in the fatigue loading condition. If the loading is static, then this is not the case. But if the loading is fatigue loading, then it can fail ahead of the stress reaches up to its particularly what you can say UTS value. Okay, so this is the endurance limit. Then we have what you can say creep. Then we have creep. So creep is related to first of all, main point is constant loading condition. Constant load means the magnitude of load is constant. We are not changing the magnitude of load, but that is related to the at elevated temperature, not at room temperature but at elevated temperature. So when any component is subjected to constant load plus with temperature, it may go through the failure which is known as creep failure or creep deformation or deformation. So if someone has to define the creep, so deformation of material under static loading condition, but at elevated temperature. Okay, it is not the case that always we need elevated temperature. There are some materials like lead. So lead is the material which is subjected to creep deformation even at room temperature. Lead, that is a creep that can experience creep at room temperature. Okay, so I hope the creep is clear to you. Okay, and this kind of creep deformations are very important to understand in turbine blades, because turbine blades are associated with the high temperature conditions and also the loading condition. Okay, so I hope ductility, malleability, resilience, toughness, creep, all these things are clear to you. So these are the few basic important properties that one must know if he or she wants to understand the further subjects of mechanical engineering, like uh, material science, like mechanical design and all that. Okay, so I hope this is clear to you. Keep watching and keep following StudiHQ for more such interesting videos. Thank you.